This is a hot glue gun, probably the most typical DIY tool available that melts these hot glue sticks to glue stuff. Isn't a 3D printer just a hot glue gun strapped to a motion controller? This is how you would explain 3D printing to someone unfamiliar with it. Yet, 3D printers use filament and not hot glue sticks. But what if we would change that? This is different from what Stefan from CNC Kitchen showed in his video, where he printed with hot glue sticks. He shredded them, turned it into filament and printed with that. When I saw that video, I thought to myself, I should be able to print with hot glue sticks directly because of the extruder I developed a while back. This thing uses timing belts to push filament, and with a little modification it should be able to push hot glue sticks as well. The reason why I want to do all this, besides thinking that this is actually pretty cool, is that I think that this could open up a whole new range of materials. Besides the apparently huge range of materials that glue sticks have, is that this big of a diameter could enable us to maybe print with extremely soft materials without needing an expensive pellet extruder. By the way, thanks to my buddy Simone for filming these clips. It was pretty hard to find good clips of a pellet extruder. Also, I think that this could enable us to print with extremely brittle materials that cannot be spooled in the first place, because they are sticks. So I bought this hot glue gun from Dremel, and I bought this one because it looked decent. It had a nice discount, and I thought it was moderately funny that Dremel also sells 3D printers. Thing is though, that Dremel doesn't want you to open it, so I had to buy a special bit for that. And the plan is to use the heater that's inside of here and just mount it below this extruder, and hopefully that works. So let's see what's inside of here. Okay. This is perfect. This is going to be a walk in the park. This is so much better than I expected. I didn't know what to expect, but before opening this I was afraid that I had to just connect it with the 230 volts directly and have it heat up the way it usually does, and hopefully that it's at the right temperature. With this design I can just, well, I'm not going to return this thing anyway. There we go. Can just remove this original heater cartridge from it and add one of these. This is a regular 3D printer cartridge. This makes things much safer because we aren't working with mains voltage. This is just 24 volts. And it's also much easier to control. The thing is though that this is a lot smaller. The inner diameter of this is 8 millimeters and the outer diameter of this is 6. But I can just buy a brass tube with an inner diameter of 6 and an outer diameter of 8, cut it to the right length, press this stuff in there and call it a day. Things are going much better than I expected. For some reason, every time when I make a video about this extruder, things go better than expected. Well, let's not jinx it and enjoy this for how long it lasts. This is going to be the 4th version of the proper extruder, and I'm confident that this is going to be the best version. I modified it to fit the glue sticks, but it should also work fine for filament. I combined several parts from the sheet material version, because we are going to 3D print it now. I also reverse engineered the part from the hot glue gun and started designing a holder for that. By the way, I'm using the cat mouse from 3D Connection, and I've got a deal with them that you get a 10% discount when using my link, so definitely check that out. I lost myself in the process again and already designed the whole hot end assembly without even checking if the extruder itself works. So before continuing, I decided to finish that extruder first by adding the last component, and that's the Revo toolboard from Duet. This board makes the wiring a lot cleaner and it can be used for other extruders just fine. I printed all the parts in the Solval SV08 out of grey PLA, which is the prototyping material for this project. If you want good bang for your buck, I can definitely recommend this printer, so check the link in the description. Okay, all the parts of this first prototype are finished. This is by far the simplest version of the proper extruder, all thanks to designing for sheet material first and now going back to FDM. And these parts can basically be printed with any decent FDM printer. So now I'm going to put this thing together and see if it's capable of pushing these hot glue sticks. I added these brass inserts into the parts. Although I've done this many times, this continues to be a very satisfying process. The bearings were a tight fit though, and this was because I still use tolerances from the sheet material design, which are a bit underdimensioned. Okay, I put this thing together and I'm pretty pleased with how it looks, but it's far from ideal. I had quite some trouble getting these screws in here. These screws are the axles of all the gears in here, and I do have a solution for that and also ordered the parts, but I'm currently waiting for those to arrive. So in the meantime, I think that this is good enough to at least do the first test. So I have printed this. This will be the hot end part, so this will be the holder of our heater element from our hot glue gun. This will be mounted below here, and it's quite a long contraption, but with this we should be able to see if we can print with these hot glue sticks. The brass tube I mentioned earlier fits like a glove, and I'm pretty pleased with this. I marked a hole for the themister and I didn't have a lot of room for error. I didn't have the most accurate equipment here, but I somehow nailed it. I turned it into a nice package with this overpriced Kapton tape and placed this in a 3D printed holder. I printed this part out of PLA, which is definitely not the right material to cope with the heat, but the silicone socks should buy us enough time to test if it works and if everything fits. I mounted the Revo toolboard from Duet, which can be controlled by the Duet mainboard using a CAN interface. This saves me quite some time and results in a neat package. Who needs that set height anyway? Some would argue that a 1.5mm nozzle is too big, but I think that this is perfect, because 1.5mm happens to be the perfect diameter for tapping M1.7 thread in there, and an M1.7 thread is needed to fit one of these tiny airbrush nozzles. I leave the rubber gasket on there because I don't think it gets too hot for that. And now we have a 0.5mm nozzle. Okay, I've connected the printer to my laptop using this local network, and I'm able to control this printer using the web interface. So the first test that we are going to do is to see if it extrudes, hopefully in the right direction. And then we have to set the E-steps. So if we say move an X amount, like 100mm, that it actually moves that amount. Okay, 10mm, extrude. Okay, it goes in the wrong direction. Due to the crimp connectors, it's easy to just cut the wires and solder them together in a different way. Okay, let's see if it turns into the right direction now. Fuck. Driver error. Phase A short to V in. I did something wrong here. Okay. Attempt number 3. Extrude. Weer de verkeerde kant op. Krijgt het teer. Extrude. Yeah. Finally. Okay. It's extruding in the right direction. Okay, the next step is to see how far it extrudes. Because right now I'm extruding, it says 10mm. This is way more than 10mm. So when I set the E-steps correctly, then I should be able to print with it with just like usual. But I have to set the filament diameter to 7 millimeters. So hopefully the slicer supports that. I have no idea. Okay, I started Simplify 3D. I'm using this slicer because it's easy to do some customization. I already set the nozzle diameter to 0.5. Let's make a new material option and call it hot glue. And I'm wondering what will happen if we set the filament diameter to 7. It just accepts it. Okay, by the way, this is not a regular diameter for hot glue. The most used diameter is 11. Also, all the interesting hot glue materials do have a diameter of 11. So the temperature that this thing runs on is 165 degrees. So this is what I'm going to set the 3D printing temperature to as well. Put the temperature to 165. The heated build platform, I don't think that this is necessary. I think I will just set it to 0 and print on a cold bed. Didn't work with PLA.
It's failing right now.
But I think that hot glue would stick to a glass plate. So I'm going to heat up the nozzle to 165 degrees. And I will do it manually. 165. Looks like it's heating up. Yes, it's heating up. So I hope that this... Oh, shit. Heater fault. It's not heating up fast enough. There's a lot more mess in there than with the Revo hot end that I had on here. I have modified the heating rate, so now it expects that it will heat up 1 degree a second, 165 degrees. Let's go. Almost at 160 degrees. So I hope that I can manually push the hot glue through the nozzle. Ah, it's coming out. Oh, okay. That's actually looking pretty good. So now I'm going to home the Z, and it homes at the top. And the only thing I have to do now is determine the offset from the nozzle to the bed. Okay, bed adhesion is not a problem with this. Let's start the print. 3D Benchy hot glue. Yes. I just hope that the nozzle doesn't crash in the bed. That would be nice. Oh, good fuck! I think the 0 position is a bit off. Ah, shit, of course. If I go to the system, I have home all. Includes the Z. This one. Ah, fuck! Hot glue is hot. 3D Benchy hot glue, come on, yes. This looks good. But even without the fans running, this PLA is not melting. Apparently the silicone sock in there does its job, and I didn't expect that. There isn't a lot coming out of there. Basically nothing. Maybe it doesn't have enough grip on the hot glue. Everything is covered in glue. And I have to go back to the drawing board. I redesigned the extruder and now it's time to print it for real. This is where the sponsor of this video comes in, Sunlu. They sent a ton of their PLA Plus 2.0 together with the Fillet Dryer S4 dryer box. Moisture in filament can cause printing problems and therefore it's advised to dry your filament before printing. You can select the material that you want to dry during the printing process and you also get better looking prints with less stringing. This PLA Plus 2.0 has a higher impact strength than regular PLA Yet this is not the best use case for the dryer box. Well, I have this several years old extremely hygroscopic nylon 6 and placed this in Sunlu's S2 dryer box which I bought a while back and pre-dried it. The new parts are starting to look great. I really like this orange color. It has some transparency to it which has an interesting aesthetic. I printed the gears out of Sunlu's blue PLA Plus 2.0 which I reckon contrasts nicely. It was very pleasing to remove the brim from these gears. The nylon has dried for almost 24 hours and I placed it in the S4 filament dryer because it needs to be dried constantly during printing. It also requires an enclosure and fortunately I've got this enclosure on the roll. I printed the hot end part out of this material and now I've got an affordable setup capable of printing this. Thanks to Sunlu for sponsoring this video and supplying me with this filament dryer and great looking filament. This is the solution I mentioned earlier. I'm using flat tip set screws as axles for the gears and pulleys. The M5 thread is modeled in the part itself and is such a tight fit that the screws stay in there. This time I designed the holes for the bearings correctly and this is by far the easiest assembly of the proper extruder I've encountered so far. Funny thing is that I was able to drive the gears using the set screws. No idea if this is useful, but still. I printed the extruder part out of PA6. Not for the looks, but because the original heat gun enclosure is made out of this material too, albeit with some glass fiber. The last step was to reconnect the wiring and I had to redo the fence because I made a stupid mistake that we can just forget. Although I really like this Revo toolboard, it would be absolutely perfect if it had screw terminals instead of these impossibly small crimp connectors. Oh well, everything is put together now. Okay, the first upgrade is pretty obvious. I added some B, or just blue LEDs. By the way, the reason why I'm using this microphone now is because for some reason this overhead microphone is picking up a lot of noise from the printer. So therefore the quite aggressive noise reduction from earlier. So sorry about that. This should be the final version, but I am a bit afraid of this part here. Because when I was reassembling it, I noticed some leaked hot glue here at the top. So I think there might be some heat creep in there. I'm going to try and print at a lower temperature. Hopefully that works. If not, then I have to redesign this part and have this fan being able to cool better. First, let's see if we can print with this as it is right now. Okay, there is hot glue coming out. Yes. Yep. Right now I'm printing with hot glue sticks. Okay, we do have a bit of an issue. Right now it's printing in mid-air and there is just a little bit of hot glue coming out. So I think that my initial concern of heat creep is a problem here. So I must stop the print and I need to go back to the drawing board again. I went back to the drawing board several times. It was getting late and I thought that I got it this time. I think I've got it now. I explained why it was failing, but it turned out I was still unable to make it print. Oh man. I didn't sleep much. I'm pretty tired. The stakes were pretty high because I already developed a whole automated rod feeding system that will be placed on top of this that can hold several rods, and it would be such a shame if I'm not able to show that in this video. My confidence level dropped, but I wasn't giving up. I'm not giving up. I'm not giving up. Come on. I made a new version. Version 3. Let's see if it works. Also, this version was not working. It looks like it's not extruding. Yeah. After further inspection, I found the culprit. I think I found the culprit and made yet again a new version where the silicone tube was held firmly in place. Guess what? This also didn't work. The guys from Matter and Form sent me their 3D scanner for my next project of 3D printing the shoes. But I decided to 3D scan the actual hot glue gun with it because this thing seems to work fine. I was able to load the 3D scan into Fusion and design a holder for it so I can fit it to the extruder directly. I had to modify the hot glue gun though and made this technical drawing that I used as a reference. I clamped it onto my super advanced milling machine and milled out the part where the extruder will be mounted, which of course went without any issues. While I was at it, I milled some aluminum profiles to the right length and mounted these together for the holder of our automated rod feeding system. I used the 3D printed mounting part as a guide to drill the holes for the inserts that I melted in and realized why I had these leaking issues. I should have placed back that ring. Oh well, I moved the heater from that second hot glue gun to this modified one, broke off a screw because my screwdriver was too big, fixed that, mounted this thing together, mounted the extruder to it, which looks absolutely hilarious, added this micro switch that will detect when the hot glue runs out. And now I've got a CAN-controlled hot glue gun, strapped to a grill plate. Welcome to the Proper Printing YouTube channel. Temperature control. Add a 100k resistor, so it's at 20 degrees-ish and doesn't give an error. Enable cold extrusion and you're good to go. I mounted these huge fishing leads to the rod feeder that is used to catch, I don't know, blue whales that will keep the rod feeding system under a constant pressure. When a glue stick runs out, it triggers an action where it will move the extruder under the feeder. A new stick is dropped into the extruder, the next one is indexed and it continues printing. But then I realized I made a mistake. Shit! The benchy was too big and the print failed. Big part of me not giving up is thanks to these guys, my Patreon supporters, and especially these top tier supporters. Thanks guys. It was also impossible to get it off the build plate, until I realized that this is an actual grill plate. I tried to print something else, but found out that I had a cooling problem. When something is worth doing, it's worth overdoing. This rod feeding was fun and all, but I had to babysit it because the switch caused the glue stick to get stuck, which I sometimes forgot and got under extrusion issues. So I bought these optical sensors, which on paper should do the trick. A quick test confirmed that this was the case, so I redesigned the extruder and mounted the sensor in there. It worked! It triggered! And it triggered again. It triggered with each movement and I was starting to run out of glue sticks. So I bought a bunch more and also got rid of the trigger problem by disabling the trigger for a couple of seconds so the glue stick has time to go further down and not cause the re-trigger. And yes, this was the solution. Now it triggers reliably and continues printing. I finally felt brave enough to try these pink glitter glue sticks. These shorter sticks are even more satisfying to see dropping down. It finished another benchy with zero user intervention, but I wasn't super happy with the result. Remember, the end goal is not to 3D print glue sticks. We are going to experiment with materials that can only be printed as rods. Yet I wanted more, so I decided to print something simpler. Now this is not a bar, this is part of a call to action. Just like this, an S, printed out of gold glitter hot glue. And now I've got this pile of hot glue that tells you exactly what to do next.